Welcome students to another lecture in the series. Let us continue with the concepts of marginal costing and break-even analysis. Further, let us take it. Okay, let's understand what is limiting or key factor. The objective of a business, we know very well, is to earn profit. But however, it is not always easy to achieve this objective because profit earning is affected by a variety of factors. Like suppose if I take an example here, an undertaking may have sufficient orders in hand, ample skilled labor and production capacity, but may not be able to obtain all the quantity of material it needs for the manufacture of maximum quantities which could be sold. So this material is the factor which limits the size of output and prevents an undertaking from maximizing its profits. Similarly, sometimes a business is not able to sell out all the products that it has produced. So in such a case, the sales is the limiting factor. That where that key factor or that limiting factor is that where your sales may get affected or limited, or your profit would get affected out of it. A limiting or key factor may thus be defined as a factor in the activities of an undertaking, which at a particular point in time or over a period of time will limit the volume of your output. So we can have various limiting factors. Here I have quoted few examples like sales, materials, labor of a particular skill if not available, production capacity or machine hours, financial resources. The purpose of studying this limiting factor technique is basically to indicate that most profitable course of action in all such cases where alternatives are possible. Okay, so contribution per unit of key factor can be calculated. Let us see. When a key factor is operating, the most profitable position is reached when contribution per unit of key factor is maximum. So for instance, if choice lies between producing product A, which yields a contribution of rupees 15 per unit, and a product B, which yields a contribution of rupees 20 per unit, then obviously product B would be more profitable. So if however the production takes 3 kg of material, which is a limiting factor, and a product B takes 5 kg, the respective contribution per kg of material would look like this. So in that case, your product A, which gives a greater contribution in terms of per unit of limiting factor, will be more profitable. Okay, let us have a numerical. This data is given to us for product A and B, direct material, then direct labor at the rate rupees 3 per hour, variable overhead at the rate rupees 4 per hour, selling price, standard time for both the products is also given. Then we need to state that which product is recommended to manufacture. When in first case we need to consider labor time as the key factor, and in second case we need to consider sales value as the key factor. Okay, let us have a look. At first we can step selling price is 100. We can check out the direct costs, that is direct material for both the products, then direct labor, then variable overheads. Variable cost comes out as 38 here. After adding these all, then we can calculate the contribution, that is your selling price minus the variable cost. 100 minus 38, 110 minus 35. Okay, so it is coming out like this. So let us see if the contribution per labor hour we need to find out. Then we'll divide it by 2 as per the given rate here, and 3 by as per the given rate. So it's 31 here and 25 here. And in the second case, contribution per rupee of sales value is also calculated by dividing it by your sales, and we are able to see the situation. From this calculation, what can we conclude? Yeah, we can conclude that product A is recommended when labor time is the key factor. Why? Because contribution per labor hour is more. We can see that our contribution per labor hour is more. It is 31 as compared to 25. What else we can conclude? That the sales volume is a very, if the sales volume is the key factor. So when B, in that case product B is recommended because contribution per rupee of sales value of product B is more than that of product A in that case. And there is one more conclusion that we can draw from this, that the sales quantity is the key factor. When the sales quantity is key factor, then product B is more profitable because its contribution per unit is higher than product A. Let us move further towards the graphical presentation of a break-even analysis. Angle of incidence. angle is formed by the intersection of a sales line and total cost when we show it graphically to show the break-even point. So that angle that is formed by the intersection of these two lines shows the rate at which the profit is being earned once the break-even point has been reached. So wider the angle, the greater is the rate of earning profits. Therefore, the aim of management will be to have a as large as angle as possible, because that would give a greater rate of earning profits. Okay. The angle of incidence is of particular importance in boom periods when sales are expanding, taking in conjunction with margin of safety. Therefore, a large angle of incidence with a high margin of safety indicates an extremely favorable position. So it is considered. Then cost indifference point, it refers to that level of output where the total cost or profit of two alternatives is equal. And such a level may be calculated when two or more alternative methods of production or machines are considered, and use of one machine involves a higher cost and a lower variable cost per unit, while the other machine involves lower fixed cost and a higher variable cost per unit. The calculation of point of cost indifference helps in a cost minimization exercise, and it identifies the alternative which is more profitable for a given level of output or sales. So a machine with a lower fixed cost and a higher variable cost per unit is more profitable when actual sales are below the point of cost indifference, and vice versa we can use. A machine with higher fixed cost or a lower variable cost per unit is more profitable when actual sales are more than the point of cost indifference. Okay, let us see the formulas. Cost indifference point in units can be calculated by dividing difference in fixed cost upon the difference in contribution per unit. And if we need to find it out in amount, then we can simply uh, divide difference in fixed cost upon the difference in PV ratio. Now let us have a look to the graphical representation of break-even analysis. It is a graphic, let us see, break-even chart. This chart takes its name from the fact that the point at which the total cost line and the sales line intersect is known as break-even point. So break-even chart not only shows the break-even point, but it also shows the profit and loss at various levels of activity. We will see that using a chart in the next slides. But let us see that what all will be portrayed from that break-even chart. First, it will show you the break-even point, means the point at which we are at a position that there is no profit, no loss. Okay. Then second, profit or loss at different levels of output. Third, it would show the relationship between variable cost, fixed cost, and total cost. I'll show you everything graphically in the next slides. We can see margin of safety, angle of incidence indicating the rate at which the profit is being made, and we can also find out the amount of contribution at various levels of sales. Let us see that one by one. How to construct that, then we'll see that. First is that some principal steps. First is that we need to select a scale on x-axis. X-axis, you know, is a horizontal line which is drawn and spaced in equal distances to represent any of these factors, either output in units or in value, either sales in units or value, or production capacity in percentage as per our requirement. Then we need to select y-axis also. It is the vertical line at the extreme left of the chart. We know that which is spaced into equal distances. And in this axis, usually cost and sales are shown in a rupee value. Then we need to draw a fixed cost line, which would be parallel to x-axis, starting from any appropriate point. Like we may start, suppose there is a fixed cost of 30,000, so we may plot it at that point. We will see that. Then we need to draw a total cost line. The variable cost is depicted in the chart by superimposing it on the fixed cost line. So thus a total cost line is drawn starting from the point on the y-axis, which represents a fixed cost. Okay, we can see that here. All the lines. We have shown units of production or sales in thousands here on the x-axis. On the y-axis, we have shown the costs and revenues in thousands. We can check out, we have drawn the equal distances here. Let us see the lines. This is the total cost line starting from, not from zero, because it is showing the fixed cost here. This is your further sales line, and then you can check out various points. This at the intersection, this is your break even point. So at this point you are not having any profit, any loss. This is the angle of incidence, which shows the level of your profitability. On the opposite, this is the dark area is the loss area. and we can check out at different levels if we locate the actual sales, and break even sales are also there, so we are able to see the margin of safety. Okay, and we are able to see the variable cost and fixed cost. I told you is marked as 60 here. Okay, so it is very easy, and a lot of information can be obtained from such kind of representation. Then let us see the uses, like what are the uses of break-even analysis. Some important uses here: it helps in determining the break-even point. Second, it helps in determining the selling price, which will give the desired profit. It helps in determining the sales volume in order to earn a desired profit or return on capital employed. It helps in determining the cost and revenue at different levels of output. It helps in determining the most profitable sales mix. It helps in determining comparative profitability of each product line. And it also studies the effect of change in selling price or of price differentiation in different markets, like home market or foreign market. Then it studies the impact of increase or decrease in fixed and variable costs on profits. Then it studies the effect on profits and even break-even points of high proportion of variable costs with low fixed cost and vice versa. It compares the profitability of various firms, and it can also help in management decision making, like they may take the decisions of making and buying or discontinuance of any product line or acceptance of any special job or so. There is one more function, that is that it helps in determining the cash requirements at different levels of operation with the help of cash break-even charts. But along with so many functions and utilities, it is having certain limitations also. Although this is a very valuable tool of management, but there are certain limitations, and these limitations arise from certain assumptions on which this analysis is actually based, which are in effect not true. Okay, so this break-even analysis is based on on a simplified model of business, which is unrealistic. So it must be applied with an intelligent discrimination, with an adequate grasp of assumptions and underlying techniques surrounding its practical applications. The assumptions of break-even analysis have already been narrated on the previous slides, and now let us have a look to the various limitations using the various assumptions, which are sometimes unrealistic. The assumption that all the costs can be clearly separated into fixed and variable components is actually not possible to achieve accurately in practice. So thereby it results in inaccurate break-even analysis sometimes. The assumption that variable cost per unit remains constant and it gives a straight line chart, that is also not always true. In practice, many of the variable costs do not observe this tendency. Most of the variable costs, no doubt, move in sympathy with the volume of production, but not necessarily in direct proportion to the volume. Similarly, the assumption that fixed cost remains constant is also unrealistic. Fixed costs are constant only within a limited range of output, and then they tend to increase by a sudden jump when additional plant and machinery is being introduced or any other such fixed asset is being introduced. The assumption regarding the selling prices that they remain unchanged as the volume changes is also not realistic. It's untrue. In practice, we can see that selling prices do not remain fixed, and the change in price affects demand. So any increase in output can be sold only by affecting a reduction in selling price, which would affect the sales line further. Then assumption that only one product is being produced and that product mix will remain unchanged is also not found in practice. The sales of various products manufactured is not always in predetermined proportion. Then we have two more assumptions here. It is assumed that production and sales are synchronized. This is not always so. So sales may fall short of production and may be capable of increase to match production only by affecting a reduction in selling prices. The break-even analysis completely ignores the consideration of capital employed, which may be an important factor in the study of profit analysis. And in spite of all these limitations, still this break-even analysis is a very, very important and useful management device, and it should be used by keeping in mind its limitations, because then alone the technique can be used effectively. So we need to use it judiciously. If you have any problems related to the topic, you may write to me. Till then, take care. Goodbye.